Hi friends, welcome to the Unit R Day 1 notes. We're picking up with the inequality symbols. In this set of notes, what we have here is the inequality symbols. We have the five inequality symbols, and a blank spot for the verbal expression for the symbol. This first one here is less than or equal to. The next one, just less than. Then we have greater than or equal to. And then the last one students actually usually miss when we talk about the inequality symbols, but it is an any symbol. It is not equal to. So the practical application of this in these examples down below, it says use a variable and an inequality symbol to represent the statement. Mr. Brumman must give at least 100 homework problems each evening. At least is your key word here. Mr. Brumman, oh wait, whoa, it's a lot of homework problems. Don't worry. Not going to do 100. That's way too much. First, let's identify what we're talking about. The variable here in this case is homework problems. So I'm going to say P is homework problems. So if I give at least, so then say P is greater than or equal to 100. If you have at most $60 to spend on a pair of shoes, then if I think about this as, let's go with A is, in this case, it's the money that you have to spend. So you have at most $60. So the amount that you can spend, the money to spend, has to be less than or equal to that 60. Then in order to hit a home run, you must hit the ball over 300 feet. So the distance that the ball travels, talking about a ball over, so over 300 feet. So B is distance. In this case, the ball traveled. Then I would say B is greater than 300. Now, each have labels associated with them. Problems, the money that we can spend, and the distance.
You can make your way to the lecture hall for your blizzard. Group 4, you can make your way to the lecture hall for your blizzard.
Alright, well there's a bonus for you. That's actually, I'm in group 4, so I'm going to go get my blizzard, and then we'll finish out with these last set of notes. I'll see you soon. Hi, welcome to the last part of the Unit R Day 1 notes. This is going to cover the absolute value and then everything else that's on Simplify for the last page. Absolute value is an interesting idea. Absolute value represents distance. And it's distance from 0 on a number line. Now, if you think about distance, distance has to be non-negative. So you can have 0 as a distance, but you'd only have 0 and positive values. You can't have 0 and negative. You can't have negative distance. So we call this non-negative. So if I ask you to simplify 23, the absolute value of negative 5, well, what's the distance from negative 5 to 0 on a number line? Well, that's going to be 5 units. Now, 24 is interesting. The way that reads, it reads is the opposite of the absolute value, or the distance, of negative 7. So the opposite of the absolute value of negative 7, the absolute value of negative 7 is going to be 7. But then we have the opposite of 7, and the opposite of 7 is negative 7. So that's how you end up with a negative, if you have a negative outside of the absolute value. 3 minus 10 is negative 7. So if I simplify this in terms of steps, then I have the absolute value of negative 7, which is 7. Now here, 26 is a little bit tricky. We have kind of these nested negatives, or nested opposite. So I have the opposite of the absolute value of the opposite of negative x, when x is, in this case, negative 1. So if I plug in negative 1 in for this, I have the opposite of the opposite of the opposite of negative 1. I know that's a lot of opposites. Whew. So if I go through and simplify this, I'm going to end up with negative on the opposite of the absolute value of 1. So then we have opposite the absolute value of negative 1, which is the opposite of 1, or negative 1. Whew. Using the absolute value symbol to write an expression for the distance between negative 7 and 3 on a number line, then simplify your expression. So if I think about the distance between negative 7 and 3 on a number line, let's go ahead and actually draw this out. So I'm going to do this over here. So negative 7, negative 6, negative 5, negative 4, negative 3, negative 2, negative 1, 0, 1, 2, and 3. So the distance between negative 7 and 3 on a number line. So if I'm talking about the distance, so this is the distance, or how many spaces I'm traveling along my number line here. So if I count all of these, I should come up with 10. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And the way that I did that is I did the absolute value of negative 7 minus 3. Now, distance doesn't matter if you go from left to right or right to left. So if I did this the same way, I could do the absolute value of 3 minus negative 7. You notice that these two values are exactly the same when they're simplified completely, because what you have is the absolute value of negative 10 here, and I'm proposing that is equal to the absolute value of 10 as well. Both of those are 10, because both of those have 10 units away. Next part. Goes through just a real quick overview of some of the review concepts that we had with simplifying. This is an area right here that I would especially encourage you in face-to-face instruction, is to work through this and try to get as many done as you can in a minute as possible, and then check with your neighbor. If you'd like, you can time yourself, pause the video, and then see how many you can get. 0 divided by 10, if I simplify, that's 0. I can't divide by 0, that's undefined. Negative 2, notice how that's written negative and then 2 to the third power. Well, I'm going to take 2 to the third power first, or 2 cubed. That gives me negative 8. And this next one, 31, that parentheses means that the entire value is squared, so that gives me a positive 9. 2 is just the only part that's in parentheses. 2 to the fourth, is 16, so I have opposite of 16. Careful with this here, negative 2 cubed. We already know that that is negative 8, but then I have the opposite of that, so this is 8. Here we're going to have this negative 2 is in parentheses, negative 2 to the fourth power is 16, and then I have that negative out in front, so this is opposite of 16. Cubed root of 125 is 5. If I take the square root of both of these, I have the square root of 25 or the square root of 81. I can simplify this. This is negative 5/9. Square root of negative 25. This gets into imaginary numbers, which you may or may not remember. So non-real is sufficient because we've just talked about real numbers. However, if you remember them from an earlier section, 5i would be what the answer would be if we were talking about imaginary numbers. And then the cubed root of negative 8 is negative 2. Hope this helped. If you have any questions, please reach out to your instructor, and have a great day. See you later.